Assalamu alaikum. My name is Shahruman Al Mahmoud. My tick number 827476. I have my friend with me, Mr. Tajuddin. Today we are going to present about the structural design pattern. First of all, what is structural design? So actually, structural design deal with designing largest structure from existing classes or object at runtime. It allows integration of new design with existing ones, like composition. It is like one kind of object structural, and another one is inheritance, is class structural. So first of all, I'm going to discuss about bridge pattern design. So bridge pattern design is also known as handle or body. The purpose of bridge pattern design are used to decouple abstraction from its implementation. It is used to avoid permanent blinding between an abstraction and implementation. Why should it we should use this bridge pattern design? So it is used when we want to hide implementation details from our clients, and it is used mainly for the implementing platform independence feature. Element of a bridge design pattern. So there are four aspects here. So first of all is abstraction, core of bridge design pattern, and define the crux. It contains a reference to the implementer. Refine abstraction, extend the abstraction takes the extend the abstraction, take the finer detail one level below, hide the finer element of the elementors. Next one is elementer. It defines the interface for implementation classes. The interface does not need to correspond directly to the abstraction interface and can be very different. Abstraction IMT provide an implementation in term of operation provided by the implementer interface. And lastly, concrete implementation. Implement the above implementer by providing concrete implementation. Okay, next, when to use bridge pattern design. So both abstractor and implementer should be extensible by creating class. Change in implementation should be no impact on client, and it become handy when we must subclass different time in a way that are orthogonal with other. So next is here bridge pattern, one of the example of bridge pattern design. So we have a draw API interface here, which is acting as a bridge implementer and concrete classes like red circle and green circle, implementing the draw API interface. So shape is an abstraction class, abstract class, and we will use object of draw API. And bridge pattern demo, our class will be shape class to draw the different color circle. So this is the draw, Java code for draw API. So we have create bridge implementer interface here. uh, so next one here, we create concrete bridges implementer class implementing the draw API interface. So you can see green API implement on draw API. So next one is for us green circle, same thing happen here, green circle implement on draw API here. So next one here is shape.java. So we have created abstraction class shape using draw API interface here. So last one here, circle.java is like we have create uh, concrete class implementing shape interface in this section. And lastly, we use shape and draw API classes to draw different color circles. So advantage of bridge pattern. So bridge pattern decouple and abstraction from its implementation, so that that two can vary independently. So it is used mainly for implementation platform independence feature. It adds one more method level redirection to achieve the objective. Next advantage we are going to say is like publish abstraction interface in a separate interface hierarchy, and put the implementation its own inheritance hierarchy. Use bridge pattern to runtime blinding of the implementation. Use bridge pattern to map orthogonal class hierarchies. And lastly, bridge is designed upfront to let abstraction and implementation very independently. Thank you. Next, Mr. Tajuddin will continue. Thank you.
Facade design pattern is another structural design pattern that is mostly used when there is multiple interfaces doing similar kind of a job. Facade design pattern provides a unified interface to a set of interfaces in a subsystem. It also hides the complexities of the system and provides interface to the client using such system or having access to such system. The purpose of facade design are one, to hide internal complexity behind a single interface. The user or the client tend to not know what happens in the background actually. And secondly, it is to decouple the code that uses the system from the details of the subsystem. And the third purpose of facade design is it and facade design is appropriate when we have a complex system that we want to expose to clients in a simplified way. Where is facade design used? There are lots of real-world examples that use the facade design. For instance, the desktop machine start button. When you click on your start button on your desktop machine, many processes uh, many processes occur, but as a user, you tend to only see the effect. That is, your computer gets powered on, but the processes of how and what happened at the background um, is not known to the user. Such a kind of design is referred to as facade. Another example is in programming. For instance, a metadata sub get connection method is used to get a connection from a database. How the connection is being gotten, how is the connection is being made, what drivers are being used to get the connection, and other processes underground are not known to the user. You just use the method to get those connections without knowing the procedures behind that. Another example of facade design in real world is the ATM machine. For instance, you want to withdraw 50 ringgit from an ATM machine. You just click on the withdraw button. All the processes involved in the background will just execute, and you have the ability to withdraw your money. Another example is when you tend to compare two browsers, for instance, a Chrome and Firefox. Uh, as we all know, those two or both of them do perform same function, but there are different levels or different ways in which they perform these functions. For instance, they use different kind of drivers, different methods of generating HTML reports or content, and what have you. Implementation of facade design. So in this example, we are going to create a shape interface and concrete classes that implement the shape interface. First of all, we tend to create the shape.java file, and this shape.java file creates an interface that has a draw method. We then secondly create a concrete class implementing the same interface, the rectangle.java, square.java, and the cycle.java. All these files implement the shape. All these three above implement the shape class. And we then create a facade class that is shapemaker.java, and this shapemaker.java is associates new class of cycle. It associates new cycles, new rectangles, and new squares. Advantages of facade design. Facade design makes it easier to use and maintain, creating a more structured environment and reduces dependencies between libraries or other packages. Facade design can be also used to collect all complex methods calls and related code blocks. In this way, respect to the client, there's only one single call. Even if we make changes to the subsystem packages classes and their logic, there is no impact to the client call. So, in a nutshell, it increases loose coupling.